So guys, welcome to our channel once again. In today's video on our WAEC Physics Exam Revision series, we have here these 10 repeated questions to answer on the topic fluid at rest. So guys, this video will be about equilibrium of bodies and pressure in fluids. So ensure to stay to the end of this video. Let's go ahead and start with the first question here. It says, in a hydraulic press, a force of 40 Newton is applied to the smaller piston of area 10 cm squared. If the area of the larger piston is 200 cm squared, calculate the force obtained. So guys, if you look at this question, well, we are given the force of the smaller piston, and we also have the area of the smaller piston. We are also given the area of the larger piston, but we don't have the force of the larger piston, and that's what we want to calculate for. So we can simply go ahead and state that force of the smaller piston F1 over area of the smaller piston A1 is equal to force of the larger piston F2 over area of the larger piston A2. So now if we use this, we're going to have 40 over 10 is equal to F2 over 200. So if we collect the like terms, we're going to have 40 times 200 over 10. So guys, if we divide this, we're going to have 800 newtons, and that's option D here. So guys, that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 2 here. It says, the knowledge of surface tension is applied in the following areas except in A, floating of a needle in water, B, manufacturing of raincoats, C, production of palm oil, D, washing of plates with soapy water. So guys, the answer to this question is option C, production of palm oil. So guys, let's go ahead and consider the next question. So that's question number 3 here. It says, a small amount of air is introduced into the vacuum above the mercury in a mercury barometer tube. The mercury level goes down because the air molecules A cool the mercury and make it contract, B, decrease the pressure above the mercury, C, increase the pressure above the mercury, D, heat the mercury and make it to expand. So guys, the answer to this question is option C, increase the pressure above the mercury. So let's go ahead and consider the next question. So guys, question number 4 here says, the apparent weight of a body wholly immersed in water is 32 newtons and its weight in air is 96 newtons. Calculate the volume of the body. Density of water is 1000 kilogram per meter cube, and then G is 10 meter per second squared. So guys, considering this, the up thrust, which is the weight of the body displaced, is going to be the real weight minus the apparent weight, which is 96 newton minus 32 newtons. That's 64 newtons. But guys, since we have 64 newtons here as the weight, the mass here is going to be the weight, which is like the force over the acceleration due to gravity. So that's 64 over 10, and that will give us 6.4. So that's 6.4 kilograms here. So since we have this to be 6.4, the volume here is going to be the mass over the density. Actually, density is mass over volume. So volume is going to be mass over density. So in that case, we have 6.4 kg over 1000 kg per meter cube. So if we divide this, we are going to have 6.4 times 10 to the power of negative 3 meter cube as the volume. So option C is the answer to this question. So guys, that's it for this question. Option C is the answer to this question. So let's go ahead and consider the next question, guys. So that's question number 5 here. It says, which of the statements about Archimedes' principle is correct? The upthrust on a body is a measure of the A, weight of the body, B, volume of the body, C, mass of fluid displaced, D, weight of the fluid displaced. So guys, the answer to this question is option D, and that's the weight of the fluid displaced. So that's it for this question, option D. So let's go ahead and consider the next question, guys. So that's question number 6 here. It says, the pressure applied to an enclosed fluid at one end is transmitted equally throughout the fluid and to the container walls. This statement is A, Archimedes' principle, B, Pascal's principle, C, Bernoulli's principle, D, Heisenberg's uncertainty principle. So guys, the answer to this question is option B, Pascal's principle. So guys, question number 7 here says, a solid plastic cube of size 0.2 meters is submerged in a liquid of density 0.8 kilogram per meter cube. Calculate the upthrust of the liquid on the cube. So guys, this is a simple one. We are going to recall that for this, the upthrust is going to be the weight of the fluid displaced. But then, in order for us to do this, we have to work with the parameters we have. So we have density here and we have volume here. So we can get the mass of the fluid displaced and then multiply that by the acceleration due to gravity given to us here, and then we'll get the weight of the fluid, which is the upthrust, right? So here, in order to get the mass, we are going to use that mass is density times volume, where the volume is 0.2 to the power of 3. So that's 0.2 times 0.2 times 0.2, because one of the sides of the cube is given. So the cube is going to have all three sides equal. So that's 0.2 times 0.2 times 0.2. That's 0.008. So when we have 0.008 and we multiply it by 0.8, we are going to have, alright, let's try that out. 0.008 times 0.8. So we're going to have 0.0064. So guys, when we multiply this by the acceleration due to gravity, which is 10 here, we're going to have 0.064 newtons. And that's it for this question. Option B is the answer. So let's go ahead and consider the next question, guys. So the next question here is question number 8. It says, a piece of metal of relative density 5.0 weighs 60 newtons in air. Calculate its weight when fully immersed in water. So we'll have that the relative density is equal to W1 over W1 minus W2. So if we have that this way, we already know that the W1 is given to be 60 Newton, that's the first weight here, and then the relative density, let's say RD, is given already to be 5.0. So we are just looking for the W2, so that's when it's fully immersed. So we are going to substitute all these. So 5.0 is equal to 60 over 60 minus W2. So here we can just cancel out these 5 and the 60. So 5 here is 1, 5 into 60, that's 12. So we are going to have that 12 is equal to 60 minus W2. So W2 now is going to be 60 minus 12, and that's 48. So guys, the answer to this question is option D, 48 newtons. And that's it for this question. So let's go ahead and consider the next question, guys. So that's question number 9. It says, in the hydraulic press, the force F applied to the diameter D of the cylinder by, we have A, F varies as D to the power of negative 2, B, L varies as D to the power of negative 1, C, L varies as D to the power of 2, and D, L varies as D. So guys, we are going to actually solve these out together. So in a hydraulic press pump, we are going to have that pressure is equal to F over pi d over 2 all squared. So it's just meant to be pi r squared, right? But r is d over 2, so pi d over 2 squared dn. So if we express this again, we are going to have that P is equal to L over pi d squared over 4, right? So then if we multiply this out, we're going to have P into pi d squared over 4 is equal to F. So in that case, if we make P times pi over 4 a constant, then it's going to be that F is equal to the constant times d squared. So F is equal to kd squared. So in that case, F varies as d squared. So that's it for this question. Let's go ahead and consider the next and last question, guys. So that's question number 10 here. It says a body of volume 0.046 meter cube is a mass in a liquid of density 980 kilogram per meter cube with 3 over 4 of its volume submerged. Calculate the upthrust of the body. Okay, so let's first of all know the volume that was submerged, and that's 3 over 4 of this volume. So 3 over 4 of this volume, let's check what that will be. So 3 over 4 of 0.046 will give us 0.0345. So guys, let's note that in order for us to calculate the upthrust here, the upthrust here is going to be the volume that is submerged times the density here, then times the acceleration due to gravity, and the guys, that will be 0.0345 times 980 kilogram per meter cube times 10 meter per second squared. So that's 338.10 Newton. So guys, option A is the answer to this question, and that's it. So this is where we end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community where we'll post major updates on WAEC examination. You can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.